All right, so we've decided we're going to do this by partial fractions. We have a factoring right there. So we're going to write 31x minus 1 over 15x squared plus 7x minus 2 equals a over 5x minus 1. We're going to write this all clearly so that the person grading it can read it. 3x plus 2. All right, we're going to, so you don't necessarily have to show that you're multiplying both sides. I mean, it's fine if you do, it would be nice, but it's not necessary. We can just take this step for granted. This is multiplying both sides by 3x plus 2, 5x minus 1. All right, and then from there, we distribute out the a's, 31x. So I'm trying to write this in sort of the minimum amount that I would expect people to write for a problem like this. 5bx minus b, right? That's good. Okay. Now here's the other thing. Like I am going to try and sort of take some shortcuts because we're familiar with the process. So for example, I'm not going to write 31x equals 3ax. Let's just jump right to what that's going to be, which is 31 equals 3a plus 5b. That's equating the x parts. You know, if you're unclear on any of this, rewatch the videos on partial fractions. Then the other equation is negative 1 plus 2a minus b. So negative 1 equals 2a minus b. Let me really emphasize that although it would be easy enough to do this by substitution, really the preferred method here is elimination. It is more efficient to do elimination because you don't have it's more steps to do it by substitution. So we want to use elimination, and also you want to keep that skill sharp. So we're going to have negative 5 equals 10a minus 5b. So then I add those questions together, I add those equations together is what I'm trying to say here. And I get a 26 equals 13a, and nicely in this case, the a turns out to be a whole number. It wouldn't have to be, but whoever wrote this problem set it up nicely so that that would happen. All right, and then I can right away solve for b. I should show how I'm solving for b. B equals 2a plus 1, and then you should say, okay, I'll put the 2 in there and I get 5. So I want to show that I've found a equals 2, b equals 5. Notice that's clearly, you know, following from the equation work above it. Then I should rewrite the integral because I'm starting that. You know, arguably you could skip what I'm doing right here, which is rewriting the integral. And you could just jump to the separated integral, 2 over 5x minus 1. Plus 5 over 3x plus 2. Some people like to write this in 2 separate integrals. You can if you want. You don't have to. So yeah, you could jump to this. That would be okay. But it's nice since we sort of interrupted our flow to restart with a complete sentence, because this is a sentence fragment right here. It's a fragment. Where's the verb? Where's the verb in that sentence? Oh, it's right there. Is. That's the verb. All right. Now this is a. Oh, now I'm going to get in trouble because I don't know the terms. In terms of what these 2 clauses are called. Well, I'll look it up later. Or actually, I probably won't. Anyway, there's a complete sentence now. So now the other thing that I would invite people to do, though, is right away say, all right, I know I'm going to pull out the 2, and then this is an ln factor. So I can go 1/5 for the 5 right there. All right, 1/5 ln absolute value 5x minus 1. Plus, and then this one's going to be 5 times 1/3 ln absolute value. Make sure you have absolute value there, 3x plus 2. Make sure you put on the plus c at this point. It's an integral, no plus c. It's not an integral plus c. All right, and then it would be nice to condense this like this, 2/5 ln absolute 5x minus 1 plus 5/3 ln absolute value 3x plus 2 plus c. And obviously, if like you really understand this pretty well, you can jump straight from here to here with no problem. Just like I don't mind skipping trivial steps. Just make sure the steps you make are clear and complete. All right, and then it looks good. All right, so that's that one. We did that integral. Woo! All right, let's look at number 2 now. We're going to do all of these, and then you get worksheet number 2 for homework. This is number 1. You get number 2 for homework. It has 7 problems on it. It was originally, written for other purposes, but here we go. Number 2. So number 2 has integral 5 over x squared plus 6x plus 18 dx. All right. So the first thing is to decide what technique we're going to use. So I should go to my sheet. You know, I mean, some people just really have these techniques in their head already, which is great. You can use the written out list if you like. On this one, I'm going to go to the flowchart, though, just to show how the flowchart works, all right? So let's look at this first. And you'll see it's the same. It's the same steps. But I created this, and I thought it was pretty cool. So there. All right. Is degree of P greater than degree of Q? No, it's not. Degree of P is 1. Degree of Q is 2. So degree of P greater than or equal to degree of Q? No. I mean, you don't have to write these steps out. I'm just doing that to show how we're working this. All right, so since it's a no, I'm not going to go the yes direction and do polynomial division. I'm going to go the no direction and drop down here. Is P equal to KQ prime, or is the degree of Q equal to 1? All right, well, it's P over Q. Well, the degree of Q is 2, so no. All right, and it's, is it P equals KQ prime? All right, so P equals KQ prime. All right, that's again the same as saying, can I do a U sub? All right, can I do a U sub? Well, I would use U equals x squared plus 6x plus 18. You know, this you definitely don't have to write. You can look and say, no, it's not du in the numerator. Right, the numerator is not du. We can see that right away. Okay, so you don't have to write this part out. This is not equal to any constant times 5. All right. So you can just by inspection just look at this and say, yep, the degree of the denominator is not 1, and the numerator is not the derivative of the denominator, so I can't use u sub, right? So that means I'm not going to go the yes direction where I use u sub and ln. I'm going to go the no direction where it asks, does the q factor? All right, so we look at the denominator, does it factor? X squared plus 6x plus 18, does it factor? Try it. No, it does not. All right, so then we're going to go the no direction. So I went yes. We're going to go to the no direction. Ding, ding. All right, what is the degree of Q? Is the degree of Q more than 2, or is it equal to 2? By the way, if it was less than 2, then we would have been pulled off up here. So it's, the only question we got here is degree of Q is more than 2, degree of Q is less than 2. If the degree of Q is more than 2, there are things to do, but we're not going there. It's a rabbit hole. See, you got the Mad Hatter and everybody. You're not going in that rabbit hole. We're not doing this Q greater than 2. There are things you can do, but learn them if you want. This way madness lies, okay? So go down, the Q, degree of Q is 2, right? Degree of the denominator is 2. That's what we like to see. All right, so what's the degree of the numerator? Is the degree of the numerator 0, or is the degree of the numerator 1? Well, the degree of the numerator is 0, so the degree of the numerator is 1. So degree of P is 1, so we're going to go this way. Oh, I'm sorry, it's 0. Degree of P is 0 because it's a constant. Constant is degree 0. All right, so we go this way. It says complete the square and use inverse tangent. All right, so now we know what we're going to do. We're going to complete the square. All right, now if all that's too much for you, like there are other ways you can sort of think of this, like more directly. If the numerator is constant and the denominator doesn't factor, then you're going to complete the square. All right, that's what's really going on. But, I mean, how many of those different conditions do you have to remember? This many. All right, so we're going to solve this one by completing the square in the next video.